So this is my old HICTOP Prusa i3. Now I bought it in 2016 and it was actually my second 3D printer. Now my first printer was the diminutive yet trusty PrinterBot, which despite having a wood frame worked pretty good actually. And I got this one due to its larger size so I could print out the planes that you see in my videos. Now it came as a kit and it took several evenings to assemble, but it was one of my channel's actually early videos. So it has served me well, and in fact it's still functional. Well, now the HICTOP company is offering a mostly pre-built printer with more advanced features than this old thing. So let's take a look at the improvements that have been made in the past 4 years.
The printer comes in a well-packaged box with a nice bag of goodies and sample filament, spool holder, Acme screw, vertical roller assembly, and the main body and control panel. Vertical assembly is made of extruded aluminum T-channel with ball bearing supported rubber rollers. Movement is very smooth. All axes have endpoint switches. More rollers on the hot end module. Drive belts had good tension from the factory. Since this is a Bowden printer, filament sensor and spring-loaded extruder are on their own separate metal platform, with PTFE tube to the hot end and braided covering to the various control wires. Though there was a bit of loose electrical tape at the end, but not a big deal. The hot end has a standard brass 0.4mm nozzle that screws into the heating block. There is a centrifugal fan for nozzle and an axial fan for the hot end area. Build plate also has belt and roller wheels on a center T channel for the Y-axis, with the power receptacle and on-off switch in the back. Various other cables are sticking out, which I will hook up in a moment. A front color touchscreen is the only input device. On the side are some cooling holes, USB cable port, and micro SD card slot. Taking a peek underneath is the 12-volt power supply of unknown wattage with cooling fan and protected terminals. Note that it has dual input voltages, so double check the selection. Now back to the bag of goodies. There's a nice selection of stuff like this part removal tool, wire cutters, Allen wrenches, screws, USB to micro SD adapter, wrench, tie wraps, and extra nozzles. Oh, and a handy nozzle cleaning tool is also included. On the included 128 megabyte SD card are the assembly manual and Cura Slicer program. The color manual is in PDF format, so any computer can open it. It has enough basic information to get started, but don't expect a lot of details in some of the more embedded functions. Assembly starts with mounting the vertical stack, which is attached with multiple screws on each side. Next is to attach the various connectors to the stepper motors, sensors, and heated bed. The Z-axis Acme rod is inserted through the top and inserted into the motor coupler, which is affixed with set screws. A ribbon cable connects the extruder and hot end components all at once. Plug in the power cable and lastly bolt on the filament spool holder. A very quick assembly. When powered up, you're greeted with a bright color LCD that is easy to see. There are 3 options on the default screen. Since I needed to level the bed, I'll start with the Tools menu, which has the homing functions. Looks like everything's going in the right direction. Though it is obvious the bed is too high. Following the manual, the next step is to go to the leveling screen. In this screen, you can quickly move to the 4 leveling checkpoints on the bed. Since I was already in the home position, I started there with the paper test. Obviously it didn't fit, so I adjusted the knob to lower that corner of the bed until a slip of paper fit under the nozzle. Normally, I would use a bubble level to help me roughly level, but I couldn't find it, so I just eyeballed it to start. However, when moving to the next level point, I heard something very odd. Yeah, that's not good. I quickly found out it was the Z-axis motor. That sound usually means some sort of binding. Loosening the Acme screw, I noticed that it was not aligned with the motor coupler when parallel with the vertical T-channel. When straight up and down, the screw was offset from the coupler. But when inserted, the screw needed to be at a slight angle as you see here. To fix this misalignment, I first loosened the motor bracket channel mount. Then inserted the Acme screw into the coupler. This allows the motor to self-align to the correct angle, where I then tightened everything back down. Now when moving to the leveling points, everything sounded smooth as butter. Go through all 4 points and use the paper technique to set the spacing in all 4 corners. It is an iterative process, so you may need to go around all points several times to get everything set. But once you're done, generally you won't have to touch it much again. Yeah, that's the good stuff. To load the filament, select the filament option and load button. Then the nozzle will start heating up. The default is 200 degrees, and when that temperature is reached, the screen gives you the option to load the filament. Feed the filament through the sensor and into the extruder. Then press the confirm button to start the auto feed. Depending on how much you inserted, you may have to press the auto feed button a few times. If all goes well, expect some hot plastic to come out the pointy end. Alright, let's print something. The included SD card includes a test print, something called a phone holder. Well, let's see what that is. After selecting the file, you get a print screen with a completion status bar, elapsed time, printer Z-layer position, hot end temperature, bed temperature, which hilariously looks like the bed's on fire, and nozzle fan speed. There are also buttons to pause and stop a print, plus other options. Warming up will take a few minutes. Alright, let's go. Oh wait, that's not quite right. So let's stop the print and double check the gap. Second try wasn't much better. Okay, everybody out of the pool.
Well, I always gotta push the envelope and try, see what I can get away with. And so I should note that this printer comes with a glass bed. This is a real nice, roughly, 3mm or so thick glass bed. It's got an interesting coating on it. I'm not quite sure what it is, but it's sort of a matte finish flat coating with a little HICTOP label on it. So since this is my first printer with a glass bed, I just was really curious what I can get away with it. Because I heard printing on a glass bed is real nice and flat. Doesn't bend or anything like some of the metal beds do. But it looks like I'm going to have to use my secret weapon, which is this. This is the Elmer's glue stick, particularly the disappearing purple glue stick. I found that this is really the best glue stick that I've found that works. Even with some tough jobs, I had some tough jobs that would lift off the bed on some of my other printers, and this stuff really sticks really well. So it looks like I'm going to have to apply a little bit of this onto the bed, and I'm going to give it another try.
So I'll just rub a bunch of glue on like this. And voila, it works! Now I get to see what the heck this phone holder thingy is. While I was printing the first layer, I also carefully fine-tuned the level position.
Still there?
I also noted how quiet the printer was. "4 hours and 49 minutes later, I had this. Using the included removal tool, I was able to pop off the print. I also noticed a set screw came out of somewhere. Turns out it came from a heating block, and once I put it back in, it hasn't come out since. Print quality of the part was very good with no stringing, though I really wish I knew what the slicer settings were. The phone holder took me a moment to figure out, but it does unfold into a pretty neat little contraption. It even has adjustable angle. Speaking of slicer settings, the S250 comes with the popular Cura open source slicer. Despite being a somewhat older version, I had no issue setting it up as the printer comes with a configuration file to import. Cura is a very good program, and while you may have other preferences, it is a good program to start with. I decided to start with a 20mm calibration cube, which I set up to print at the highest resolution. Didn't look like I had quite enough sample filament left, so I used a spool from my inventory. So out with the old, and in with the new. The touchscreen is very responsive. Oh, oops, I forgot to disable the brim setting. And I noticed the first layer is a bit too thin, but the part looked good. So dimensionally, the cube was very close in the X and Y dimensions. The Z direction, however, was short by about 0.5 millimeter, which is not surprising as the first layer was a little off. Next was a real torture test, as I had a new RC model to print out using some new LWPLA filament from eSun. This would take dozens of hours of print and should be a good test of the printer's durability. The S250 did pretty good, though I did have a surprising event happen while printing.
Well, it looks like I had an unexpected test for the HICTOP printer. The power just went out in my house, and since I don't have the printer connected to a UPS, the printer lost power. So I ran up to the room to see what happened, and it looks like something really neat. It looks like the printer remembered that the power went off and remembered where it was, and it's giving me the option to press the resume button. So I'm going to press the resume button and see what happens.
It did leave a small blob where it stopped, and that will need to be sanded down. But the resume feature otherwise worked just fine. Look for a review video of this plane and filament in a future episode. While experimenting with the filament settings, I somehow clogged the nozzle. Removing the nozzle is quick and easy when heated, but requires 2 tools. Sorry, I was too lazy to find a wrench. All the spare nozzles are 0.4 millimeter. There, found my wrench. Happy now? And we're back in business. Not done yet. Next up was nylon, which requires a hotter tip than PLA. First print started okay, but started under extruding halfway through. Once I made the retraction settings less aggressive, it worked fine. Retraction will still need a little tweaking, but it was a decent print. Next up was some TPU, aka flexible filament. Now flexible filament can be a little tricky to print, and I was curious how a Bowden type printer would do. Loading went well. That's a good sign. I need not worry as it printed just fine. I needed to turn combing on to get rid of some tiny blobs on the inside since you can't use retraction on TPU. Lastly was some ABS filament, which took some trial and error as setting the bed temperature too high overpowered the power supply output. I finally settled on an 80-degree bed temperature and 220-degree hot end temperature. which did take about 10 minutes to heat up. It ended up printing just fine, but apparently was pushing the limits of the power supply to do so. Time to see what happens when you run out of filament, so I literally cut the print short. Once the sensor detected the line cut, I was greeted with a loud alarm and the print was paused. Hey, not bad! Now we can go into the option menu, then the filament screen, and unload the filament. However, I did find you can't feed the filament backwards through the sensor. So I just pulled it out through the side. Feed the new filament back through, then go back a couple screens to print the status menu and select resume. The S250 then dutifully resumed printing. Oh, let me remove that bit of ooze from the nozzle first. I wanted to try some speed tests, so I got a baseline time at 30 millimeters a second, which took just over 20 minutes. Yeah, that looks decent. Now let's double the speed to 60 millimeters a second, which is the advertised max speed. And go! Wow, almost exactly half the time at just under 11 minutes. Again, the print looks good with just a minor hiccup on one layer. Just for giggles, I decided to print at 80 millimeters a second, which is above the recommended max speed. The print finished just fine, but was only slightly faster at 9 minutes 40 seconds. However, the print looked fine. Actually, slightly better than the slower speed. If you have a lot of files on the SD card, the printer arranges the newest one last. As a final note, I thought I would look back through the other menus. The preheat screen lets you manually heat up the extruder, or print bed. You can select 10, 1, and 5 degree increments. The plus button increases the temperature by the set increments, while the minus decreases the temperature. The close button turns off the selected heater element. Move screen lets you move all the axes in different increments. The 10 millimeter increment moves things a bit quicker. You can even select 0.1 millimeter for very fine adjustments. If you find the stepper motors are locked in position, you can turn them off in the homing screen. The more screen has some cryptic icons that when pressed seem to home the head and nothing else. Lots more options in the settings screen. Manually adjust the hot end fan speed with presets or fine tuning. The About screen shows the current firmware version. Continue option, which I think is for continuing a paused print. Lots of language options. Simplified or traditional Chinese, English, Spanish, French, Italian, Russian, German, and Japanese. Machine setting has several embedded menus. Machine type seems to hint the same firmware is used in different types of machines. Print volume settings, and several other obscure settings. I like how you can disable the filament sensor, and apparently there's an option for an auto level sensor. There are a bunch of temperature settings for both the nozzle and bed where you can set limits, set points, and even PID gain settings. Not done yet. Need to change stepper motor directions or calibrate the steps? This is where you do it. There's also acceleration and jerk settings. No need to mess with G-code. Curiously, the menu states the advanced menu is not functional, but it does have some neat options. I'm guessing it's a future firmware update. Again, there are some options which I have no idea what they do.
Well, there you have it. What a difference a few years makes. Now, there's definitely big improvements in the display and interface over the old knob control. Now, the touchscreen looked good and performed very well. The advances in firmware is very apparent and worlds better, which of course to be expected. Now, assembly is very quick and you can go from open box to first print easily within an hour. And now, as you saw, the build volume is big enough for printing planes, and the factory settings gave me accurate prints. Now, I also noticed the Z-axis looks to be the tallest of all my printers. Now, there were a couple of nitpicks, however. Now, the bed's Y-axis is only supported by a center rail, which I personally thought was a little bit wobbly. Now, however, I couldn't see any defects in the prints because of it, so I guess that's not really an issue. More annoyingly, though, is the black powder surface coating on the glass bed comes out pretty easily and would also often stick to the bottom of the prints. Now, I ultimately just scraped it off with a razor blade, which actually gave me a much better bottom finish. I also wondered if I could change the file sorting order so that the newest file is displayed first, but I really couldn't find that setting. Now, that said, the printer performed great, and other than the power supply fan noise, it is actually very quiet. The menu system is easy to navigate and is generally intuitive. I was actually a bit surprised at the variety of filament types it will print, as long as you are patient with tweaking the settings. Now, that said, this printer is a great value for the money and is easily available on Amazon, so see the video description for details.